he joins.
We are live now.
Perfect. Hello, everyone. Welcome to the day 3 of the demo day. This is the V4 Hookathon finalist. We have 5 projects with us today. Super excited. This one is going to be a long one, but an interesting one. The first one is Lick Vibe. The second one is OG Boost. Third one being LP Incentivization Hook. Fourth one being Pado Hook. And the fifth one being Bore Sage. Sorry if I butchered that. But yes, super excited. We also have a panel of judges with us, and the format is as follows. Feel free to introduce yourself at the starting of the presentation, introduce your problem statement, the proposed solution, the technical details, and the conclusion. Keep it Try to keep it within 15 minutes so that every project can have their fair share of presentation times. Followed by that would be 3 to 5 minutes of questions by the judges, that is if in case they have any. But yes, this is the order we'll be following. And again, yeah, welcome Chef Momo, Chef Mist, and Michael. Thanks for being over here. Excited to kick off day 3. And yeah, with that being said, I won't take a lot of time. We can hop on to the first presentation of the day, the first demo of the day, Lick Vibe. Um, yeah, feel free to present your screen and talk about your project now.
Thank you very much. Okay. Hi, everyone. I'm John Ansaf. I am a representative of Big White. And our team includes 2 members, Levi, A2N, and me. Levi is software engineer with 10-year experience, and I'm a data scientist. Now I will shortly introduce Levi to you. Levi used the Bollinger Bands concept to calculate volatility and reward token amounts for liquidity addition with Pancake-3 hooks and rabbits. We realized that liquidity providers face higher risk during periods of market volatility or when liquidity is low. Without proper incentives, LPs may be unwilling to add liquidity to pools, leading to reduced liquidity, higher slippage, and less efficient trading. So we have proposed a solution. Rewarding LPs with incentive tokens calculated based on volatility levels and delta amount during critical periods helps mitigate risk, stabilize liquidity pools, and maintain a healthy trading environment for decentralized exchanges. With the solution, Liquid is one of the first functional hooks utilizing Pancake-3 hooks integrated with RabbitZK technology. To implement the solution, we found how to identify volatile periods and how to use off-chain calculated results to determine the reward token amount for liquidity providers. About volatility calculation, we see that we can, based on historical price data, candlestick analysis, and trade volume. So we show historical price data. The volatile periods can be identified with vertical bands with two levels, inside bands and outside band. So we use vertical band concepts like vertical band upper and vertical band lower is calculated by SMA and standard deviation. So we need to calculate standard deviation. Levi implements two solutions to calculate the mean and the standard deviation of a list of historical square root price x96. First, we use storage slot data from the pancakes with 3 pool contract. This solution works on both the testnet and the mainnet of BSC and Ethereum. However, it's difficult to use with the pancakes V4 pool manager. The second solution, we use swap event logs from the V3 pool contract or V4 pool manager. This solution can integrate with both V3 and V4. However, as of now, the V4 pool manager is only available on the testnet. After proof and submit the mean and standard deviation to Revit service, we update them into Hook smart contracts to calculate reward tokens when a user adds liquidity. You can see the formulas like that. Reward tokens equals pay reward points plus alpha multiply a square root delta amount multiply absolute square price x 96 subtract mean divide standard deviation. Reason why we choose this formula because first, base reward points. We want to ensure all LPs having reward amount, and alpha can be adjusted by liquidity pool manager purpose. We use square root for delta amount corresponding to liquidity addition to reduce increasing rate based on delta amount. And this is a linear component for reward calculation based on increasing volatility rate. And here you can see the picture on the right-hand side. And you can see the reward token is changing when volatility is changing. So now I will run the application to show how it works. You can see the logs and the application automatically pay for send request. After finish, we can check the transaction on the Revit request contract, smart contract, and the volatility update events in the Hook contracts. In conclusion, Liquid successfully applied Revit ZK technology to pancakes V4 hooks, implementing technical solution to identify volatile periods. And we introduced incentive mechanisms to encourage DeFi participants within the PancakeSwap ecosystem, enhancing engagement and rewards. Thank you for watching. If you have any questions, feel free to ask me.
Can you please show the code where you have implemented the hook?
Yes, we will later. Yeah, can you see? This the formula reverse boy equals base boy plus etc. And this is the condition that the volatile periods with the two levels, inside band and outside band, with the polygon band upper and polygon band lower. So we set the alpha zeros and alpha 1 for purpose of pool manager.
Yeah, okay. And so where are you using Previs? Which data are you pushing to the contract?
Could you speak again?
Yeah, so where does the Previs implementation comes into play? The Previs part of it, on what data is pushed on chain?
Yes. Like I said, we use two data, storage slot data and swap even logs like this. And we use Revit SDK to to calculate this data.
Yeah, okay.
Yeah, this is a storage slot data. You can see a square price x96 here, and this is a swap even logs we show in the presentation.
And just to clarify, like you're using Brevis SDK to basically to calculate the mean and standard deviation of the price. Is that correct? And using this kind of like the
Yes.
the mean
Yes,
standard deviation.
Okay, thank you very much. We use Revit SDK, yes, to call this data and calculate the mean. So I will see you. I will show you some code in here. Yeah, you can see in the circuits that go receive. We use SDK in the circuits to to calculate the price and mean and sigma. Yeah, sigma is corresponding to standard deviation and mean. Yeah.
Okay, I see.
Chef Miss over here. So just one question is looking through your code. Have you thought about if users can actually do something funny from the hooks? For example, like in this case, if the users add and remove liquidities, they're gonna mean unlimited rewards point in this case, or is that the intention? Yeah.
Sorry, but I cannot hear clearly. So can speak again.
Basically, if I get what you're doing correctly is that whenever users add liquidity, you will give them some reward point.
About liquidity, yeah. You asked me about the liquidity.
So
yeah.
what happens if users just add and remove? They will be able to get infinite points, right? Through this way.
Yes, although I'm not clearly about the question, plus I will answer like that. We use the square root to reduce the increasing rate based on that amount corresponding the liquidity addition. For example, if the volatility in our band maybe is lower of the polygon band lower, maybe it's very rich for LPs. So if we want LPs add the liquidity to the pool, we need to reward them. So reward tokens, and the alpha can be adjusted by the purpose. Maybe alpha can be increasing to incentive LPs add the liquidity to the pool. Do you have any question?
Yeah, so I think that was it for the questions, I'm assuming. Thanks a lot, John.
Yes, thank you very much.
Yeah. Now we move on to OG Boost, which is the second presentation of the day. Please feel free to team present your screen and talk about it.
Hi there.
Hey, Alex GM.
Yeah. Our project is called OG Boost. OG Boost is an open yield farming protocol which offers the ability to create incentives for OG liquidity providers. There are two of us in the team. I am Alex. I'm the blockchain developer, which also took care of the backend side, and Andrei is the front-end dev. We previously participated in two hackathons this year that are closely related in theme to this one. So we took part in Uniswap before Incubator hackathon and won the second and third prizes for the two of the hooks that we developed in there. And earlier in July this year, we've participated in Net Global in Brussels, where we won a prize from Arbitrum Stylus and from Uniswap for our project that consisted of created a cross-chain coincidence of ones DEX. Okay, so before formulating the problem, let's take a look at some data from DeFi Llama. So with blue, we have Uniswap V2 and Uniswap V3 total value locked, or let's say total liquidity. And with green, we have PancakeSwap liquidity. So from launch, PancakeSwap was pretty much correlated with Uniswap total liquidity, but since early 2023, it started to diverge, and PancakeSwap liquidity is slowly bleeding out on this chart. So we know Uniswap dominates Ethereum and Ethereum L2s, while PancakeSwap is still king on Binance Chain. That's true. But on this chart of TVL per chain, we have Binance Chain slowly decreasing. So its share in early 2023 was over 12%, and now it is less than half, 5.4%. So basically, since 2 years ago, main Ethereum L2s have been gaining a significant share, and now so those are Arbitrum, Base, and Optimism are surpassing Binance Chain today. So back to the problem. So how do we find new ways to increase TVL for PancakeSwap? Our solution comes in two parts. So first, open PancakeSwap to other incentive providers. That means allow token founders, for example, to offer incentives in their own tokens so that they can attract more liquidity to pools that they want, whatever pools that they want. Currently, all farming in PancakeSwap is rewarded with cake. Yes, there are some means for teams to attract LPs via farm auctions, but it is way less accessible than just allowing founders to offer incentives permissionlessly. My only option as a token founder today is to create my own farm, which means development costs, security risks for LPs, and higher marketing costs and other things like that, other disadvantages. Instead, I could just use PancakeSwap to add my incentives, and LPs could benefit from them without being exposed to unnecessary risk. That means no need to stake position NFTs to unknown MasterChef-like contracts. Second solution would be to attract big LPs from other DEXs. And we do that by allowing incentive providers to offer a multiplier to LPs that are proved to have earned fees above a certain threshold externally on other DEXs, probably even other chains. So technically, we do this by distributing farming rewards based on the proportion of earned fees in the current pool. Technically, we implement that by using data from PancakeSwap v4 CL Pool Manager and by using a hook to store and compute the distribution of tokens correctly. That is based on the proportion of fees earned and not based on time, as they were doing back in the days. And then we use BrevZK coprocessor on top to push proofs of past on-chain activity of LPs. And there is activity from other DEXs and other chains. So that in the contract, we know what LP to assign multiplier rewards. And that is because these LPs are proven to have earned large amount of fees on other DEXs. And as for demo, we have a recording here. We also have a UI for configuring reward distribution, but we had to use scripts to prepare the pool, to add liquidity, perform some swaps. And that is because there is no PancakeSwap v4 UI at the moment. So here we deploy the contract that contains reward distribution logic, and it also has a v4 hook. And then we have to initialize the pool. So we're initializing the v4 pool. In this case, we chose a pair of rep BNB and the token we called Cake3, but that can be any other token and the team could have control over. And now we have to add liquidity. So we have three actors, Alice, Bob, and Carol. Alice and Bob are LPs, and Carol is a swapper. And here, Alice is adding liquidity to the initialized pool. So she'll add a bit of RepBNB and a bit of Cake3. She got a token ID there, which is basically the identifier of the NFT that is managing the position. Now it's turn for Bob. So with Bob, we'll add the same amount of liquidity for the same tick interval. Okay. And then, okay, so both Bob and Alice have added the same amount of liquidity in the same tick interval. And now we have Carol. And Carol will perform a swap from RepBNB to Cake3, and the fees will be distributed equally to Alice and Bob. And notice that the fees, not the farming rewards. Cool. Now we have everything set up. Here we are launching the front end. So we have an incentive provider, which is basically, let's say, a project founder that connects the wallet and wants to add incentives or token rewards. So he chooses the pool, selects a reward token, which can be any ERC20, desired total amount of rewards that are spread through a period of 24 hours in here. Now, for the multiplier part, we want to attract LPs that have earned RepBNB fees in amounts greater than 10 for the past 30 days. And for that, we assign them OG status, and they will get a 2x multiplier in Cake3 rewards. Okay, so the configuration is done. We've sent the transaction. So just to recap, 10 Cake3 tokens are configured to be distributed during 24 hours. To LPs that add liquidity to Cake3 RepBNB pair, and that is based on the proportion of fees that they earn in those 24 hours. On top of that, OG LPs will receive twice as much. And back to the console. So here we are pushing Brevis proofs that qualify Alice as an OG because she earned more than 10 wrapped BNB in the past 30 days. And here we need to run a script in order to poke the positions for Bob and Alice so that V4 contracts will update the fees that have been earned since they added liquidity. So we need to do that. And we can already see that Alice has earned, even if Alice and Bob have earned the same amount of fees, Alice has twice as much incentive rewards compared to Bob. And here we connect with Alice's wallet, and if we check in the list campaigns, if we check, we can see her rewards that she has earned so far. Yes, so these are farming rewards. The usual LP fees she will withdraw via PancakeSwap interface, PancakeSwap V4 interface, but here she's claiming the additional farming rewards offered by the incentive provider. And because Alice is also an OG, she has earned twice as much comparing to Bob. Okay, transaction is confirmed, and we can see that the tokens have been transferred to Alice's wallet. Cool. So as a conclusion, we saw TVL is declining for PancakeSwap, and to mitigate this, OG Boost implements two solutions. Open farming to founders by allowing them to offer their own tokens as incentives for LPs. And the second solution is to allow the same founders to assign multiplier rewards to OG LPs and thus attract liquidity from other DEXs. And that's about it. So if you have questions, I'm open to answer.
Hey, hi, Chef Miss here. Just
Hi.
wanted to check what data are you pushing to Brevis that includes the fee information?
Yeah,
Is
sure.
it just
So
the balance of, yeah.
the data is very, very simple. So we basically need to know that a given LP has earned at least a given amount of tokens in one whatever coin. And in here, if we'll take a look at the circuit, so we'll basically have, for each LP, we'll have the wallet address of the LP, the wallet address, the address of the token, and the amount of the given token. Now, in the demo, hypothetically, the Alice's address has earned more than 10 rep BNB. And that's everything we need to be able to compute or to allocate a multiplier to Alice. And
Yeah, but I guess the question is like, what kind of like on-chain data you're pulling in order to get the LP fee information? Yeah, I guess that's something
yeah.
maybe.
Yeah, so we have the event. So when you, for example, for Uniswap V3 and PancakeSwap V3, you have this claim event when you claim fees as an LP. And basically, this is the identifier of the event. And in that event, we have the wallet ID that has claimed the fees and the amount of the fees that have been claimed. And all these are filtered and put into the circuit.
Yeah, won't this lead to an incorrect calculation because not every LP will withdraw or claim the fees during
That's
the
true.
Yeah, and have you
That's
thought of a more accurate methodology, meaning let's say something like how the internal fees is calculated in the core using
yes, I
global.
agree with you. That's not accurate and not up to date. And usually the front ends will display more accurate information because they're recalculating on the front end the fees. But I don't know any other ways to. So basically, you have to trigger the calculation of fees. And even in the demo, I have poked the pool so that the fee would be updated for Alice. Other way, other way, there is no event on chain that would say that this uh, wallet has earned that amount of fees so far. So unfortunately, this is the only way we have discovered so far that you can actually prove from on-chain data that certain LP has withdrawn or has earned fees.
Yeah, okay. And you initially mentioned that not only for a given pool, but let's say an OGLP who has earned fees uh, across multiple protocols or multiple pools.
Yes, yes,
So
of course.
seems like that's not supported as well, right? It's only for a given pool right now.
Well, for the demo, yes, but basically you can extend this to whatever. So in the configuration screen, as you saw in the UI, you could choose the pool that you want to, or let's say the amount that you want, the minimum amount that you want your LP to have earned in a given token, so that that LP will be an OGLP. And in the backend, we're querying just one pool. But we can do that for any amount of pools and any amount of dexes as long as and they're pretty compatible. So Uni v3, Pancake v3 have the same event basically. And then that is also extensible to whatever other variation of AMMs.
Okay, got it. Thank you.
Yeah, so we can basically get data from whatever chain we want, from whatever EVM chain we want.
Yeah, okay. Thanks.
Thank you. Other questions?
Yeah, if that is it, we can move on to the next one. Thanks a lot, Alex, for the presentation and answering all the questions. Appreciate it.
Cool.
Um,
Thank you very much.
the third presentation for the day is LP incentivization hook by Kamal. Kamal, feel free to take on the stage.
I hope my screen is visible.
Yes, it is, but I can see your Zoom screen.
What about now?
Yes, yes, I can see the presentation.
Okay. And so, hello everyone. My name is Kamal, and I'm a blockchain developer with 5+ years of experience in building innovative blockchain solutions. And I have been building on DeFi since last year. ETH Istanbul was the first one in which I built a DeFi solution, and we received the first prize in Gearbox protocol. And so that is the way where I have interest in DeFi, and I decided to participate in PancakeSwap V4 Hook. Um, let's go with LP incentivization. So this would be the agenda of the presentation, the problem statements. There are three key problem statements, and then the solution, features, and the demo and architecture. So the problems that we are aiming to solve, the first of them being low liquidity during volatile periods. So in traditional liquidity pools, during periods of high market volatility or low liquidity, LPs often withdraw liquidity to avoid impermanent losses or capital inefficiency. This behavior further exacerbates liquidity issues, leading to poor market conditions for traders. The solution for that, how we are implementing, is the utility-based rewards mechanism dynamically incentivizes LPs to provide liquidity during the volatile or the low liquidity periods by using Brevis, a ZK coprocessor, to verify historical on-chain data. The contract adjusts rewards in real time, encouraging LPs to maintain liquidity when the market needs it the most. Second key problem is the lack of long-term commitment from LPs. So many LPs add liquidity only for the short periods, which destabilizes the liquidity pools and creates an unreliable market environment. Without proper incentives, LPs frequently remove liquidity prematurely. So for that problem to solve, we have the time-based and milestone-based rewards address this issue by offering progressively higher rewards the longer liquidity is provided and incentivizing LPs to maintain liquidity over consecutive days. This creates a more stable and predictable liquidity environment, benefiting the entire market. The third key problem is the inefficiency in reward allocation. So, traditional liquidity incentives are often one size fits all, providing equal rewards regardless of the amount or impact of the liquidity provided. This leads to inefficiencies where large liquidity providers or consistent contributors do not receive adequate compensation for their contribution. To solve this, we have the amount-based and boosted lockup rewards mechanism, which ensures that rewards are proportionate to the liquidity provided and the length of the lockup periods. This incentivizes large contributions and long-term liquidity lockups, ensuring that LPs who contribute more receive a higher reward, which maximizes the capital efficiency of the pool. So we built this solution, which is liquidity incentive hook, which is a contract, is a customized pancake swap V4 hook designed to incentivize the LP liquidity providers through various rewards mechanisms. So this contract leverages Brevis ZK coprocessor to fetch and verify the historical on-chain data, enabling dynamic and data-driven reward adjustments based on the liquidity conditions. Here are all the features that we provide with our liquidity incentivized hook, which are utility based rewards, so which incentivizes LPs during volatile periods, or low liquidity based on verified data from Brevis. Time based rewards proportional to the duration of liquidity provision. Amount based rewards, higher rewards for consistent large liquidity contributions. Milestone based rewards incentivizes incentives for maintaining liquidity over consecutive days. So these are all the different type of reward system that we have integrated in our PancakeSwap V4 hook. Cross-platform rewards. We are working on cross-platform rewards, which would be a future potential to integrate cross-platform rewards using Layer 0 or Brevis. Boosted rewards for lockup. So incentives proportional to the duration of liquidity lockup. So let's go to the architecture now, and let's see how the contract functions. So basically, this architecture shows you how the workflow is on the LP incentivization hook. And after this, I would be going through the contract part. So here we have our liquidity provider who adds liquidity. When an LP adds liquidity, the after add liquidity function is triggered. This function calculates rewards based on various criteria that I discussed, including the duration of liquidity, market conditions, and lockup time. Then we check the conditions for various reward systems. So for utility-based rewards, the contract requests proof from Brevis, which processes the request and submits a ZK proof of historical liquidity and volatility data. So it requested the proof from Brevis, and Brevis proof submitted, and Brevis processes the data, and with that the ZK proof is generated, and we have a handle proof result function which verifies the proof. And the other reward systems are time based. So time based are calculated using block.timestamp, amount based rewards, and milestone based rewards. So together, all these reward system, we have a function which adjusts the reward multiplier, and it adjusts the incentives and stores the LP information. So after that, when it is done checking, it grants the incentives. And so after this is the first part, and the second part becomes like LP removes the liquidity. So if an LP removes the liquidity from the pool, uh, the after remove liquidity function checks for milestones and uh, applies any penalties for early withdrawal. Milestone rewards are distributed if the conditions are met. So let's now. So that was the architecture diagram of how the V4 hook functions. Now let's see some of the functions. So here we have adding liquidity. So as discussed earlier, here is our after add liquidity function. So this gets triggered obviously when an LP adds liquidity. and it checks various of the functions as discussed. So it checks whether an event is emitted, liquidity added, and with the block.timestamp, which is further used to calculate the milestones. This function calculates reward based on various criteria, including the duration of liquidity, market conditions, and the lockup time. It is all the functioning that the after add liquidity function is doing. Let's go to the second. These are all the contract interaction, which are the functions present in the smart contract. So the second being calculate reward multiplier. So we have this function which calculates the rewards based on provided requirements. So it computes reward multipliers based on time, amount, and the conditions, as you can see here. So this is like time based reward, the utility based reward. I've made sure to add a comment so that the contract is furthermore readable. So this is time based reward, the utility based reward, the params. So this is the amount based, and this is the boosted rewards for the lockup duration. So we have like greater than 30 days, then a multiplier would be added based on the months the LP provider has had locked the liquidity. The third and fourth being is low liquidity period, determines low liquidity conditions using previous data. So in order to, since the smart contracts are, as we know that smart contracts are contracts which do not interact with the real world, but we needed a check on how to find if the liquidity period is low. So for that we are utilizing Brevis, and here we are utilizing Brevis proof to determine low liquidity period. It requests the Brevis proof. Before all that, if you want to deploy the contract, we provide with pool manager Brevis request address, and we are implementing here the CL base hook, and we are extending CL base hook and Brevis app so that we can request with Brevis. And then we have a function which is handle proof request, which is very important function, is here. So this is a callback function to handle proof results from Brevis. So it has like this VK hash, which is to verify the proof using the designated verification key, and it processes and verifies the proof data submitted by Brevis. The last one being after remove liquidity, which I discussed earlier, handles logic for removing the liquidity, including the milestone validation and penalty application. So if you go ahead and you can see here, after remove liquidity, and it checks whether to grant the milestone rewards or not, and penalty for breaking the lockup period. So if you break the lockup period, if the LP liquidity provider breaks the lockup period, then a penalty is issued. So this makes LP providers do not take out liquidity from the LP pool. The security considerations. For the security considerations, we have ZK proof verification. So the contract uses ZK proofs from Brevis, as said, to ensure the authenticity of the data used in the reward calculation. This prevents the manipulation and maintains the integrity of the incentivization process, so that an external actor cannot manipulate the incentivization process in the smart contract. So all that is handled through the ZK proofs from Brevis. And then we have the penalty mechanism. So penalties discourage early withdrawals, ensuring liquidity stability and rewarding long-term participation. There are more features to come and that I'm working on. The first one being cross-platform incentives. So exploring the integrations with other platforms like Layer Zero for cross-chain liquidity incentivization. So I have worked on an application which is called cross-chain DeFi with ZeroSign, which utilizes Layer Zero for doing the transaction. So imagine you are on Ethereum, and if you want to add liquidity on the Polygon using the Pancake Swap V4 hook, you can do so using just signing the transaction. It utilizes the MPC multi-party computation powered by the ZR sign. So you just have to sign the transaction, and your liquidity would be added to that liquidity pool. So I'm working on this protocol, and the second being advanced data analytics. So we will use additional Brevis features to further refine reward mechanisms based on broader DeFi market trends. Currently for the hackathon, we did this. And the next thing is future enhancements, which are, as I said, the cross-platform incentives and the advanced data analytics. And I believe strongly that the future is multi-chain. So we need Layer Zero or Brevis for integrating multi-chain applications, so that the contract, though being on a Polygon, can check whether how much liquidity provider has added liquidity on other chains as well. and that would help in the reward process. And so this is our team consisting of me. I love to build multi-chain application. I go with the Twitter name 0xKamal7. And thank you so much for watching. If you have any question, feel free to ask me. Thank you so much for listening. Also, we have this front end deployed using the deployed in the code. So this front end, you can deploy the contracts on the local, and you can utilize this front end for testing of the platform or the V4 hook. Since there was no platform utilizing V4 hook, I decided to make like this platform, and where you can add liquidity, remove liquidity, and you can check your rewards. These are currently like placeholders, but this would be utilized based on the reward system that I was trying to create. And then you can see your statistics, where you would be able to see the total liquidity provided, current lockup period, lockup progress, and milestones. This lockup progress is present on various DeFi protocols, and so I decided to add this up so that the LP provider can see his lockup progress. If he has logged for 30 days, he can see how much progress he has made. So that was for the project.
Hi. Just going through your GitHub repositories. Do you know where is your Brevis circuit?
Yeah, so Brevis circuit is, I hope my screen is being shared. So you can go under source, then you can go under the Brevis app dot as well. And you can see that this is an abstract contract that we have to implement so that it utilizes Brevis. And so this liquidity engine device utilizes the Brevis circuit. So you can, here we have a request Brevis proof, which requests the liquidity and the volatility. And here we have the handle proof request.
Is there
It
the
decodes.
circuit.go?
I wonder if I had pushed that. I think it is missing. You're right. I would be adding this after this demo, because it's been like 20 days since I made the project, and I think I forgot to push that circuit, but I would be adding that after this presentation.
Actually, like without the circuit files, Chef Miss just mentioned, I don't think the current demo will work, right? Because there's no way to generate the proof and basically verify the proof for one of the criteria you're mentioning, right? So
Are you asking about the circuit, the previous circuit?
yeah.
I think it's missing. I would be adding it after this.
Yeah, but one question, like so I think you should you demonstrate like the front end. That does that like front end actually work? I just wondering like
Yeah. So
is it
actually, yeah. Please go on.
no, go ahead. Yeah.
Yeah, so the front end, I had made the front end in order to test the pancakes of V4 hook that I was building. So the hook is compiling correctly in the VS code, and so I made the front end, and then I just fell ill. I am ill right now, but yeah, I wanted to present whatever I made. The front end would work if you, but you need to supply the contract addresses. For example, if you deploy the contract on Sapula, then you would have to select the chain and write the contract address, and then the front end would work. Does that answer your question?
Yeah. Okay.
Okay. Thank you so much for asking. And yeah, Basically, but there was no front end for pancakes for V4 testing of the hook. So I decided to build a front end that would add like an extra functionality in the project. But yeah, it would work if you deploy the contract and then supply with the chain, like all the connect wallet and everything is set up. The UI is set up. Only thing is that you would need to provide the contract addresses. Basically, it was for me for testing and checking if the hook is working or not. Any more questions?
Yeah, I guess no, Kamal, for now. Thanks a lot for the presentation.
Thank you, Mishika. Thank you. Thank you for hosting this, by the way. Yeah, thank you.
Yeah, with that, we move on to the fourth demo of the day, which is Pado Hook by Xavier. Um, yeah, feel free to take on the stage, Xavier.
Okay, yeah, let me share my screen first. All right. Hi everyone. I'm Xavier from the project Paddle Hook. So our project basically leverage some power of we call on-chain and off-chain transaction proof to empower a DEX. And this is some basic introduction about the project. I'm Xavier. I'm a cryptography engineer and a researcher, mainly focusing on the cryptography and the privacy research. And we also have two other team members. Wenjun, he is a full-time full-stack engineer responsible for the whole architecture and the implementation. And also we have another mate, Tate. He mainly responsible for the whole product and the general process design. And we have won the second place in Ether Beijing Hackathon last year. So yeah, some basic introduction about the paddle hook. We trying to build a specific DEX using the power of Pancake V4 hook plus the Zkiko processor, and also with some other technology we call MPCTOS. So let me first introduce what's the problem. So basically, I think there's a lot of issues which are relevant to the decentralized exchanges, and beyond them, some problems are mainly related to infrastructure layer. So there will be some compliance and regulation problem, like how we can enable some specific DEX for grouped user, for example, for the institutions, or how we can create some certain DEX pool, which can make sure that under the regulation and can which can make sure that we are under a certain jurisdictions. And also some other problem, like when we have more data, if we have more user data, then how we can leverage for this data, whether we can use it for some like marketing or for the user profiling purpose, make sure the DEX will be created better or can be targeted for specific users. So, and also maybe for other trading business. So the problem will be converting to a general problem, like how we can create specific pool or swap with more data. And because of the option that V4 Hawks provider, we can build a very flexible and their their multi-dimensional data, which can combined with their contract and with the DEX contract. So we want to add some
I think there's some connection issue at his end. Xavier, can you hear me?
Oh, sorry. Yes, can hear. I was disconnected due to the network issue. Yeah, maybe I can restart. Start from what I
Sure,
missed.
sure.
All right. Okay. Sorry. Did I explain about the problem already, or I need to start with the solution?
Yes, yes, you were talking about the problem itself.
Okay. Yeah. Okay. Yeah. So the problem becomes how we can create a specific DAX or pools with more data, and luckily we have the options like V4 hooks. I mean, it provide a very flexible capability, so we can enable customizable logic within the contract, and and also we want to integrate with other data related technologies like a previous Kiko processor, and also plus with Pardo MPC2S technology we have. So then we want to combine these three components together to create such kind of solution. So basically, we will have a whole contract here, and also it should combine with some DEX contract as well. So basically, there's a user, and if a user he simply submit a swap transaction, then there'll be a whole contract to verify if the user has satisfied certain condition. So it will check some eligibility for users' attestation status, and will query some attestation data on the attestation contract which has been deployed already on the blockchain. And if the result returns true, then the whole contract can enable the user to process with his operation, like add liquidity or make a swap transaction. So, and then the problem becomes how we can build such kind of attestation-based solution. And we already using the Pardo SDK, and with the Pardo extension, it can, if the user can operate on that extension and he can create a user attestation on that, and he simply submitted this attestation to the attestation contract. And then if he want to do some DeFi operation like swapping or adding liquidity, then all the checking logic will be processed at the backend, and the user will be directed to a yes case if he has passed the verification and he can do his operation, or no if he didn't have enough attestation on chain. So this is the whole picture of the solution we provide. And before going to the details of the technology, I want to give some background information about what is the MPC2S attestation, because this technology provide a key a very important data, which is about the users off-chain attestation, and we want to link this data to bring it into a smart contract to make sure that it can be leveraged and to be work with DeFi use cases. So some information about MPC2S. It's about the cryptography protocol, a multi-party computation based on the transport layer security. And if you are quite familiar with TOS, it's a very widely used Web2 protocol, which makes sure your conversation between your client and the remote server is secure and confidential, and integrate. All the conversations will be encrypted for your communication session. And normally, with the MPC2S technology, there will be a role we call a tester, like here, and he will be monitoring the conversation between the client and the data source server, say a Google server or Binance server. And he will make sure all the data coming from that server is correct. It's not a different API endpoint or a different fake data. So, and a tester will not see any piece of raw data because all the data are encrypted, and the encryption key we call the session key actually is only held by the server and the client. But in this MPC protocol, the key will be split into two parts, one held by the attester and one held by the client. And if the client can correctly prove with the attester that that piece of encrypted data is really coming from the TLS channel, then the attester will doing some blind signing, running some we call interactive zero knowledge proof protocol there, and to make sure that data is correct, is authentic. But actually he cannot see the raw data. So this is very secure for the client privacy perspective. And he will sign on that piece of encrypted data. The client can further provide the data to some verify or to a contract, and they can verify the data source correctness. So this is a basic idea how MPC-TLS protocol works. And there are some advantages, like we can using this protocol to provide the authenticity for the off-chain data. Like I can prove I really have a certain amount of Bitcoin in the Binance exchange without without exposing the exact number. I mean, we with this attestation approach, we can still have the privacy there. And also, I will not be able to cheat because all the data authenticity is convinced by the TLS protocol layer and also by the MPC protocol. So basically, there's no way to cheat with fake data. And also approach are quite lightweight. It means you can run this CK on your browser, and this approach supports arbitrary type of data source with arbitrary computation. So which means you can prove everything. If only, I mean, if the data is coming from a certain API endpoint, then you can do the attestation protocol. So this is some basic knowledge about MPC-TLS. And okay, let's jump into our solution details. So basically, we have a CL. We implement a Oracle hook, CL transaction Oracle hook here. And what we did with the V4 hook interface is we implement the before add liquidity and the before swap interface, which means we want to make sure we can make sure if the message sender really satisfies some condition, like he really have some attestation, then we can allow him to be processed with these two interface. So this is some code here which we implement with the V4 hook, and also we integrate with previous SDK, which means we want to use previous on-chain attestation capability. So we integrate with our project. We set up a Node.js server, integrate with the SDK, and the JS server will try to query the user wallet's address with the done interface to get his block data. And we set up a local prover server to generate the ZK circuits and run some proof generation, and we submit the proof to the previous contract, and then we'll store it on the Paddle contract later. So, and the attestation will return the proof, which is verified by the Paddle server, which has been signed it, and it will return to the extension. So this is the whole workflow of how if the user operates on the extension, want to generate the on-chain transaction proof, how he did it with the previous framework. So okay, now next I want to give some live demo show about how we did. So but due to the time restriction, I already did some steps. So I first deploy a Paddle hook contract already with the transaction hash here on the BNB testnet, BNB chain testnet, and also I already created a test pool which has two type of tokens, the token 0 and token 1. So now I want to do a test. I have a wallet A, which I already put some attestation there. I will show you later. And another wallet B, which have no attestation. And I want to test the result, how they process with different operations. Now let me switch to the code. Oh yeah, maybe I can show you some inner logic here. So this is a transaction article code, and the key thing we implement here is about the check logic, and basically we implement the detailed logic of the add the liquidity and before add the liquidity and before swap operation. And you can see there's a key function called check attestation. And if you go to the details of that function, so simply there it will just do simple checks like if he can get partial attestation with two number, like I must have one on-chain attestation, which I want to prove I have made some previous transaction on the BNB chain, proof and generate a ZK proof by the previous. And also I want to have another attestation. I want to make sure I did some spot trading. So here I made a test value here. Want to check if the user had did some spot trading in the past 30 days. So basically there will be two attestation checks here. And if the user passes attestation, then he will be processed with the operation, and if not, then he will be just revert that transaction and will get a fail. So let me show you the attestation status here. Okay, so this is a Pado extension, and I've already logged in to some wallet here. So now the wallet start with 96. So because this shares a whole session, so there's no attestation about the wallet 96, but these two attestations are created for the address C8. So remember they have been created, and if you check it on the blockchain, sorry. Yeah, I already opened the page here. So these are the first attestation for the okay. So these are the attestation for the address 8, and it give you some meaning like I did some transaction on the BNB chain created by the previous framework, and this is another attestation for the off-chain data. I have made some not this one, but this one should be. So issue with the network. But never mind. I think the network works, but that attestation framework failed. So never mind. So these are the two attestation, and then now let's switch to the hook contract here. No, so first I test with a wallet address. So private key, no attestation, and if I simply edit the code here. So this is for the wallet B. So remember this private key, the owner of the private key don't have any attestation, and let's see what happened. Oops. It looks like I have some network issue here. Let me just switch to another RPC node. Let me try to use another RPC node here. Okay. Okay. So actually the script here is run some swap operation. I just change it to another node, RPC node, to see if it works. So this is some script, like I can do some add liquidity and also do the swap operation. Okay, it compiles the file and so work on the transaction. Okay, the results have been done. You can see there's a fail report, which means I don't have enough attestation for this wallet address. And if I simply switch to a new wallet, just to change the private key name here to private key ATT, and I need to change the code here. We use a different wallet and rerun. Take a few seconds here. Slower than before. Okay, some results come. So yeah, waiting for the transaction confirmation. So I think I can find the transaction hash already. Okay, yeah. So this is a transaction hash, and if you lock it into the BNB test and scan, query it here. So this is some transaction, do some swapping here, from C8 to the swap contract, trade the point zero one point one amount of token 0 to token 1. So made a successful swapping operation. So the only difference is I have the attestation for this address C8. And but for the another one, I don't have the attestation which has been created. So this is pretty much about the code. And okay, some conclusion here. Yeah, basically we provide a combined approach, combining the DeFi with advanced cryptography. We're using the V4 Hawks with previous Zk coprocessor approach and with MPC-TOS attestation approach. And they want to make sure this on-chain and off-chain data can be both useful for such kind of financial use case. And the interesting thing is our approach can be highly scalable, not only to the financial, to the trading, but you can think about like we can provide a KYC approach. Like I want to create a swap which is suitable for the institution swap, and I want to make sure the users they have passed some KYC or AAM check, so I can create the KYC attestation of the by the MPC-TOS approach, and then check with the V4 Hawks. So, and also I can create some other interesting approach like want to check if user has some assets within the hold in the centralized exchange and want to leverage that kind of sensitive data, create some zero-knowledge proof for that, and then combine with the V4 Hawks. And another advantage is all the zero-knowledge proofs are quite lightweighted. And also, this is an asynchronous approach, meaning the user don't need to do some attestation creation within his swapping operation. I mean, he can first create some attestation, make sure he satisfies the condition, and then be processed with the DeFi operation later. So there's no way to then it doesn't affect his user experience in that case. Yeah, I think so. This is pretty much about our project and about the technology and the basic idea, conclusion. So yeah, thanks for the time. Any questions?
Victor, Momo, Mist, if you guys have any question, please feel free to ask.
Yeah, any questions?
Yeah, I'm good. I don't have any question.
Yeah, all good on my side as well.
All right. Okay. Thank you.
Okay, perfect. Thanks a lot, Xavier. Thanks a lot for the presentation. And with that, we move on to the fifth project of the day, of the demo day, which is Pour Her Sage by Matt Alex. Mm, Matt, feel free to come on and talk about your project.
Yes. Hi. Thanks so much, Mishika. So let me share my screen. Yes. So we're the last presentation for this pancake swap before. So thank you for listening and joining in. So to begin, hi, the pancake swap team, Chef Mist, Chef Momo, and also Victor from Brevis. I'm Matthew with my teammates Kevin and Ite, and we're building Vorhersage, which is an unlimited upside tokenized prediction market. So Vorhersage is German for prediction. So this is what we're looking for now. The team is three of us. So I'm Matthew. I currently work as an engineer at Partior. There's Kevin, who was from OKX, and Ichie was from Bybit here. And then our experience with V4 comes all the way back to from Eat Brussels, where we want Pancake Swap, the most innovative hook for Eat Brussels for our token launchpad. We also won the Uniswap V4 prize there at Eat Brussels. So thanks, Chef Miss, for guiding us back then in Brussels. It was nice chatting with the team and so on. So we're happy to be able to present our next idea here. So the main problem we're trying to solve here is current prediction markets have limited upside. So if you see poly market or same equivalents here, the upside will only be from odd. For example, like today is 50% for Kamala, and when Kamala wins, you only get 100%. So it's only a 2x. So the problems are you are not able to get rich quick. And the second problem is you are dependent on market makers, because how poly market works is they use a CLOB, concentrated liquidity order book. So you need to incentivize market makers to provide liquidity around the price range. So what differs from us and how we try to solve it is we believe that with PancakeSwap hooks, we are able to solve it using AMM model here. So instead of just 2x or capped upside basically on the probability, in here 1000x is in theory possible. And to solve the liquidity problem, we use AMM, which is the basis of PancakeSwap, to guarantee order execution here. So we don't need to incentivize market makers here, because instead of using a traditional LP curve of people LP, we use a single-sided liquidity here. So why this problem to begin with, and why this? So what we see is meme tokens are in the market used as a proxy for people to start predicting events. So if you see Solana, example like this coin Solana on Solana, Trump and Kamala, people use them as proxies for the election. So if you're a Trump supporter or you believe Trump will win, you will buy more Trump, and vice versa for Kamala. And we see this speculation happening in events where you can see people are using this with more than 500K daily volume and more than 40,000 degens holding these coins. And the question that occurred to us is, why not formalize this when people are using it to predict outcomes and elections? Why not actually formalize it to make it into a prediction market on top of AMM model? And then that's what PancakeSwap V4 comes to about. So maybe the question now is like, okay, why AMMs instead of conventional order books? So in AMMs, we do, for example, in concentrated liquidity, with Pancake V3 and V4, you will have early ticks. So how it works is we provide single side liquidity for the ticks, and then the early ticks means that whoever buys in early, we incentivize them for early investors so they can get low price. And then how ticks work is they will slowly increase as more people buy, put their USD, see for example, and then get there. Trump token or so on. And second is the price is no longer restricted. I mean, compared to like poly market, so it's only restricted based on the min and max ticks that are possible. Yes, so let me show a demo on what we have now. So feel free to capture. Just talk about it, Kevin.
Yeah, sounds good. Thanks, Matthew. So this is I'll just be quick on the formula. So this is a simplified version of the V3 price to tick formula. So as we can see in the price formula and tick, with the with the tick become increasing, the price will increase exponentially based with the base of being 1.0001. And if we go down where we plot basically to show basically if our model, our prediction market model really have a PMF here. So if you look at the yellow area, right, this is where actually the tick spacing or the ticks is actually being in the lower part, where that means each tick spacing correspond to a lesser price increase, meaning like the price doesn't increase exponentially as fast as it would in the higher tick basically. So this is a good place where we incentivize the early investor to basically believe early. Like I think a very good example is in the Kamala presidential election, right? No one will actually believe in her before Joe Biden stepped down. So this is where the early believer can be incentivized in the prediction market using AMMs. And in the red area, right, is basically where the majority of the news happen and people start buying Kamala to win the election. And when the green area happens, it's actually a perfect time for those early believers to be incentivized exponentially comparatively to the other book system, where the maximum profit that you can get is basically $1. So here, we're using our AMM models, we are able to incentivize those early adopters exponentially as it should for their belief early in the market. Yeah, moving on to you, Matthew.
Yes, thanks. So that was a brief intro to AMMs. Give me a second. Okay, so we start talking about the architecture a bit on how we work, and especially where the V4, Pancake V4 stuff happens here. So there are three main players here. The first is the creator. Second and third are the traders, yes or no tokens. So in this case, a creator will initialize a market. Let's say, will Trump win, yes or no? They initialize the market, and when you initialize the market, what we do is we have a hook that deploys outcome tokens, yes outcome token, no outcome token, and we seed single-sided liquidity for a certain price range from X to Z, X to Y here, and we call it V4 pool manager. And then in this case, this is done, and we also deploy Oracle. Second is after that, the creator can start the market and allow trading. So before this, the market was frozen. We just disabled the hooks, but now we can allow the hooks to start trading. So now trader yes will start buying yes tokens with USDC, and trader no will start buying no tokens with USDC, whether or not Trump will win. Afterwards, the before after swaps will be triggered. And what are these before after swaps used for? We track them on USDC in the pool. So how much is in the pool, in the yes pool and no pool and all the outcome pools, and we track for the before and after swap here. And for the other, the before after swaps are also used to freeze the pools before trade begins and after settlement. So those what the hooks are used for. And then after this, let's say we're done trading. Now the creator say, okay, I want to settle the market as yes, as the winner. We chose the creator for simplicity here. And the outcome will be settled on the Oracle, saying yes is the winner. So once it's done, the prediction market hook, since they provide single-side liquidity, they're able to now move the fund from the losing side, move it to the winning side now. And this happens in one single transaction. So the USDC from the trader no will move to yes. And then last but not least, once the funds are in for the yes, which is the token, the winner, the yes trader just claims the portion of USDC for yes, and the no trader loses their money. So this is what we do.
So Brevis powers our loyalty program. So we identified three main advantages of using Brevis. So the first one would be a fee discount implementation. So you can think of it as applying a reduced trading fee for eligible users based on loyalty tier. And best of all, this is enforced with Pancake swap hooks. I would say that this is like not implemented yet, but this is part of future works where we are looking to explore in that area. Then gas efficiency for creating off-chain computation based on customized campaign. So for our use case, we actually utilize Brevis by creating customized circuit for a particular campaign. So for example, like let's say the top two users for a particular prediction market, we have an EB to identify like the top performers based on certain events, and then create a customized circuit based on it. Yeah, so next. Yep. So this is how let's say if we were to do a loyalty program on chain. So let's say if you want to maintain a leaderboard of maybe 100 users, assuming we have like a struct storing, let's say, various fields, maybe for a 32 byte slot. So these are some of the opcodes that are really computationally expensive. So yeah, so you just imagine like one reordering of the whole leaderboard costs about $37, and doing like 10 reorders is like $372. Of course, this is a very simplified case, but it's really hard to create a loyalty program on chain. So Brevis really helps us for this particular use case. Next. Yep. So in
Yeah, so before
conclusion,
we go, yes,
okay.
thanks so much, Isha. So there's one more thing I want to show here, which is the demo of what we have now. So in here, we'll just do a short demo. We pre-recorded to make sure everything works. And in this short demo, we have two users here. There's a winner and loser. So there's two tokens, Tyson and Jake. So Tyson here will be the winning side. So the user will buy Tyson. So as you can see, the transaction happening. So once the user buys Tyson, the price will go up here. So you can see now, in this case, the yes token, which is Tyson here, is received from the winning side, the winner, the trader, and the USDM, which is the stable coin, goes down in amount as per the amount shown here in 10 and 1,000. Okay, so now let's look at from the losing side or the trader B side. So in here, let's focus on the Jake token, which will be losing here. So the loser, or not yet actually, but the trader will put in how much they want to buy in Jake tokens, and then they start buying Jake tokens. They swap 15 USDM to Jake. So now they have about 600 Jake tokens now, and the price goes up here. Okay, and then we can see on MetaMask, transaction is done. We can see the USDM decreasing and the notification increase. Yep, here. And then now we change the account to admin, which is basically the market creator, and we want to settle the market, which means that we want to determine who wins and loses here. So in here, we determine who won, which is Tyson in this case. And now the market has been resolved. So Tyson won. So whoever bought Tyson tokens can now claim for USDM, and the other side cannot claim. So now you can see the yes token, 500. You can start claiming, and we can start claiming here. So let's see how much USDM before. So there's 490 USDM, and now we want to claim. So there should be 490 plus 10, which is the initial amount of USDC, plus 15, which is the losing side. There should be 515 USDM. Yep. So yeah, we have 515 USDM here. Okay, sounds good. So in conclusion, what our main USP is beyond just normal prediction market is we can make 1,000x. We help traders make 1,000x. It's possible. And what we believe is meme coins are social, prediction markets are social, and combining these both of them is like a perfect fit here, because with social prediction meme coins and prediction markets you can see on poly markets, people chat, you can combine them to make a completely social experience for this. And third is customizable work experience with Brevis. There's off-chain data, as what Ichi mentioned, which are enforceable by pancake swap hooks. So yep, that's a bit about our stuff. Thanks.
Yeah, hi. So one question on my side would be, how do you verify the outcome which is submitted?
You
Yeah,
mean
so
by, sorry, you're saying?
you
Yeah,
want to
maybe,
take this or
sure. Can I confirm, Chef Momo, right? You mean outcome meaning the market outcome? Is that what you're referring to? This part? Is that what you're referring to, Chef Momo?
Yeah.
Okay. So in this example, for demo, to make it simple, we trust the creator to do so. But what we see in the market happening now is, if you see poly market, they use a UMA Oracle using crypto economics, basically economic security, right? So if how we can see it is in the poly market is you have a UMA Oracle, and then if you believe that someone has submitted a false proof, so the one who submits the proof submits if it's yes or no, they want to deposit some amount, X dollars or something. And then if they are found to be fraudulent, it'll get slashed. And then if there's a dispute saying, okay, it may be wrong or right, then it'll be depending on the UMA or UMA token holders to vote to vote on this. That's one way we see. Another way we can see, we can use like different mechanisms like eigenlayer, AVS, or something to settle this. But definitely it's a problem, especially because these prediction markets are very non-black and white. And one key thing that we need to do is make sure the requirements are really described, like a really legal kind of sentence and statement. Because if you say, like example, did Trump win or no? And then you must be specific. What does win mean, right? Does win mean like he gets enough votes and electoral college would determine him by this moment? And if not, what happens, and so on. So yeah.
Yeah, okay. Thank you.
Yes.
And also just
hi.
to be, go ahead.
Oh, okay, thanks. I just want to look at your hooks. You mentioned you haven't integrated Brevis yet, is it? Because from the hooks, I can't see anything about taking Brevis without
yes,
it.
we didn't have the time to introduce the hooks for that part yet. With regards to creating, let's say, a loyalty program based on some sort of proof. So how I imagine it to be implemented is querying it based on a certain uh, query that we had originally, based on how, let's say, a particular loyalty program tier would be like. It could be like in terms of like trading volume. It could be things like most transaction done on chain. So so it's really customized in that aspect. Then we can incorporate like maybe through some sort of like a Oracle or something to do, let's say, before a swap. We could do like a check if let's say if that person is eligible, and then so
Okay. Yeah, thank you.
If those are all the questions, I think that was the last presentation for the day. Thanks a lot, Matthew, for the presentation and answering the questions.
You're
Um,
welcome.
yeah, and thank you everyone for attending. Just to keep everyone very informed of the timeline, the demo day, this was the third day of the demo day. The winner announcement would be done on 24th October. So yeah, stay tuned by then. And like I said, thank you everyone for attending and showing us what you've built, and the judge panel as well to be here and look at all these presentations. But yeah, that's it for today, guys. Thanks a lot and have a good day.
Thanks everyone for joining.
Thank you.
Thank you. Take care.
Thank
Okay, bye
you.
bye.